Hello, my dear students. It's Svetlana again with you. Let's add a bit more beauty to our project. Let's make it so that the enemy cube, after destruction, doesn't just disappear, but elegantly falls apart into pieces. To achieve this, update the asset folder, which now includes a new file named Enemy1 Cells. As always, you can find the download link in the description. Open the project. Check the 3D cursor. It should be at the origin. If not, press Shift S, then 1. Now, let's import. There will be several objects, so we need to create a separate folder for them first. To create a folder at the same level as the others, select the root directory in the outliner. Call Scene Collection. Click the Create Folder button. Rename the new folder to Enemy1 Cells. To ensure that the imported objects go directly into this folder, select it. Now, in the File menu, choose Import FBX. Specify the path to the props folder, select the file, and click the Import button. In the middle of the scene, you'll see a cube divided into 8 parts. All parts should be inside the Enemy1 Cells folder. Now, in the same place, at the origin, we need to create an empty object in the form of a cube. Let's scale it down a bit. Don't even think about using the S key for scaling. Go to the properties of the empty object and decrease the size parameter. A value of 0.45 should work well. Rename the empty object to Enemy1 Cells. It's okay if the empty object's name coincides with the folder's name. That's acceptable. Now, we need to parent all the pieces to the empty object. Don't try to select the pieces in the viewport, there are many, and the ground is obstructing our view. It's easier to do this in the outliner. The sequence of actions here is crucial. Since the empty object will be the parent, it should be the actively selected item. If we were selecting objects in the viewport, the empty object would be selected last. In the outliner, it's the opposite. Select the empty object first, then holding down the Shift key, click on the object farthest from it. The empty object will remain active, and the other objects will be added to the selection. You can see this by the color of the selection. The active element has a brighter color. Now, move the cursor to the viewport, press Ctrl P, and choose Object. In the outliner, all the pieces of the cube are now hidden inside the empty object, similar to being in a folder. In the viewport, if we select the empty object and move it, all the child objects will move along with it. Every detail is important. If you've succeeded so far, we can continue. Now, we can lift the empty object to the height of the enemy. The enemy's transformation point is at a height of 0.4. So, select the empty object, press G, Z, 0.4, and press Enter. Move the empty object beyond the scene boundaries. I'll place it opposite enemy number 1. Let's create a new material for the debris. It will be the same as the enemy's material, just slightly darker. Select the first piece in the list. Go to the material properties and choose an existing material from the library named Enemy1. Now, create a copy of this material by pressing the button. Rename it to Enemy1 Cells and use the value slider to make the color darker. Now, we need to apply this material to the rest of the debris. And, of course, we won't be selecting each one individually and choosing the material from the library. We'll do it like pros. So, the first piece is selected with the material already applied. Hold down Shift and click on the last object in the list. Now, all the debris is selected, and the colored piece is the active one. Move the mouse cursor to the viewport. Press the Ctrl L key. And in the menu that appears, choose Link Material. All the debris pieces are now colored. Let's move on. The preparation is done. Now, let's get to the code. Open your favorite logic node editor. Go to the enemy collision branch and find the place where we remove the enemy. Before removing the enemy from the scene, let's spawn the debris. Shift the deletion blocks to the right and add the spawn object by name block. Oh, almost forgot. This block only works with objects not currently in the scene. So, one last touch for the parent, empty object. Select it, go to the object properties, and uncheck the spawn option. Note that you don't need to remove the spawn parameter for the child elements because it is inherited from the parent. Let's go back to spawning the debris. As always, select the scene. In the name field, you need to specify the name of the empty object. It's easier to copy and paste it than to type it manually. The children checkbox must be active because the empty object should spawn together with the debris. Now, let's set the coordinates for the spawn. Retrieve the getObjectTransform block and connect it to the transform channel. Leave the object field empty because we will need to take the coordinates from the owner of the branch. Run the game, shoot at the enemies. If the enemy turns dark after death, it means everything is working. Now, let's add physics to our debris. This time, we'll add physics through code. For this, we need a new logic branch. Let's name it Enemy Cells. Attach the new branch to the empty object immediately. Get the onInit block. When the empty object appears, we need to take all the child elements and sequentially add physics to each of them. Physics can be added using the Add Rigid Body block. However, we have a problem. We cannot select the empty object because physics is needed not for the empty object, but for the debris. We can't specify the name of a specific debris piece because that object is not present on the scene after loading. We will dynamically spawn empty objects, and each spawned empty object will have its individual set of debris. Here's what we can do. After spawning, we'll refer to the empty object, take all its child elements, place them in an array, and then, using a special loop, add physics to each element in the obtained array. So, let's get the array loop block. This block takes an array of values and executes a chain of code for each element in turn. Connect it to the getObjectChildren block. This block accesses the selected object and returns all its child elements as an array. That means, if we leave the object field empty, we will have an array of objects from the 8 debris pieces. We will feed this array into the array loop block. Then, in the loop, we'll take each element of this array and add physics to it. Just don't forget to connect the value channel to the object input. If we run the game, we'll see that the debris pieces, right after appearing, fall through the flow. This happens because the floor lacks physics, and the debris cannot interact with it. Let's select the flow, add a rigid body in passive mode, and change the collision shape to box. Run the game again. Now, the debris pieces remain on the floor. They accumulate, and other enemies, as well as the player, interact with them. I suggest not burdening the system with unnecessary collisions. In the physics properties for the flow, let's open the collision section and activate the second checkbox. This will mean that the physics for the flow will belong to a specific group, Group 2. A bit lower there is a collection filter mask section. Turn off the first checkbox and activate the second one. This means that the flow will consider collisions only with objects from the second group. Now, let's move to the code. On the Add Rigid Body block, activate the Advanced parameter. The block will become larger. We need the last two parameters. In both of them, change the value to 2. This will mean that the debris will be in collision group number 2. and they will only interact with objects from the same group. So, in fact, the debris will only interact with the flow. It's getting better. Now, let's add a bit of chaos. I want the debris to scatter in different directions, like from a small explosion. Let's try to achieve this using the apply impulse at location block. Connect it as follows: control signal and rigid body. First, let's try entering the value 0.2 in the z-axis in the force section. Let's see what we get. Much more interesting, isn't it? However, the explosion is always the same. So, let's get the random vector block. Specify the value range from -0.2 to +0.2. Connect it to the impulse channel. Now it looks beautiful. The final touch. The debris shouldn't lie on the floor forever. They should disappear after some time. Let's add the sleep block. Connect it to the done channel. Set a delay of 3 seconds. And after that, remove the owner of the logic branch along with its child elements. This means removing the empty object along with the debris. Now, let's do the same for killing enemies with an explosion. Let's go back to the enemy collision branch. Find the place where we kill enemies with an explosion. And insert the copied debris spawn before the removal. Now everything is perfect. That's it for today. Cheer up Auntie Sweta with a like and a subscription. And to top it off, leave a comment. Goodbye for now.